Okay, so good morning, everybody. If you are just listening in or just signing in now, and you have your video and microphone off and you want to ask a question, make sure you type it into the chat and I'll kind of keep an eye on it and try to answer it as we go. Also, for those of you that are talking live, I'm going to do the best I can to keep working on this doc cam. And if I write off the page or I forget to move it up or something, then make sure you shout and tell me to scroll it up so you can see it. It's having a little bit of trouble focusing, but I think as my hand moves back and forth under it, I think it'll work a little better for us. Okay, so let me share with you our calendar and some ideas that I was talking to Will about while you guys were signing in. Here's what I've got planned for us. This was last week. Last week, we tried to talk a little bit about the end of sampling distributions and talked about building confidence intervals for a population parameter. In particular, we wanted to estimate the mean of a population using a sample. We saw that there were two situations. One is when we know the standard deviation of the population, and the other one is when we don't. Of course, it's more often the case that we don't know the standard deviation of the population, in which case we estimate it using the standard deviation of the sample. This takes us to section 6.2 in that if we're going to estimate the mean and we're going to estimate the spread, then we get an estimate and an estimate. That's more error introduced. And what happens is that the distribution of sample means turns out to be not normally distributed anymore. But the good news is we know how it's distributed. It's distributed like a student t-distribution. And the process for building the confidence interval is the same, except that we need to use the area under the t-curve instead of under the standard normal curve. And so hopefully you guys had a chance to look at a few questions in the homework about 1 and 2. Today, what we want to talk about is building a confidence interval for a population proportion. So instead of estimating the mean of the population, we'd like to estimate the proportion of the population that responded in a particular way. So we might do a survey and say how many people think that the president is handling this crisis well, and then maybe, I think maybe I saw one yesterday that said 60% of the population plus or minus 4%. So what we would like to do is figure out how they're coming up with that margin of error. And that's what we're going to do today. Thursday of this week, we're going to talk about a little activity on Hershey's Kisses. It's we're going to be building a confidence interval for the proportion of kisses that land on their base if you just toss them. And so if you'd like to participate in that activity, then you need to pick up sometime when you're out all gloved up and masked up and hunting for toilet paper this week, pick up a little bag of Hershey's Kisses so that you can follow along with the activity as well. It's a group thing, so we're going to need to be able to post our individual results so that we can share them with each other. And I'll show you how we're going to do that on Canvas on Thursday. That will get us officially back, on the week of the 6th through the 10th. And on that Tuesday, I would like to take our Chapter 5-6 test. I was talking to Will about it a little bit earlier. We were saying that it's going to be the same as normal, except that you will get your test in Canvas. You will answer and respond in Canvas and then submit it when you're done. I'm going to have it be, this time around, I'm going to have it be open for the whole day so that you have some flexibility in when you can sit down and do that. You can certainly still use your calculator and the back of the book and Symbolab or not Symbolab, but Desmos to use a calculator or StatCrunch, whichever one you like. Now, later on, when it gets to be time for the final exam, we're going to need to do something a little more formal for proctoring. And what I'm most likely going to ask you to do is sign in with your video so that I can sort of keep an eye on you as you're doing your test. And of course, that also gives the benefit of you being able to ask a question if you get confused or have some questions in the middle of your test. But more information about, the exact format of, proctoring the final as we get a little bit closer. So that's the calendar. Of course, we're going to start chapter 7 next week and then keep going. It looks like we're going to try to do 7 and 8 for sure. And then we'll see how much time we have left. We might do a little bit of chapter 9 as well.
Oh, I have a quick question.
Sure.
So for the exam for chapter 5 and 6, is it gonna be like a timed test on Canvas for a specific day, or are you gonna be sending it like as a PDF and me printing it and then sending it back to you? I don't quite understand.
Okay, so what I was thinking is that I would open it for the day so that there's not a time limit. You can go in there anytime, and we're talking about next Tuesday. Okay, and I'll open it at the beginning of regular class time, and I'll leave it open until midnight. And so anytime during the day or all day if you want, you can work on it. What I'm thinking is that I will put the test in Canvas itself, and so you'll answer the questions directly in Canvas. And I'll send some directions and we'll figure it out. And of course, I'll be available online and also by email to help you if you have some technological problems or even some questions about the test itself.
Okay, thank you.
That help? Okay.
Yeah.
Yeah, so we're going to shoot for next Tuesday, and you should just plan on either the regular class time or sometime later on that afternoon to work on it. Okay, other questions about the calendar or what to expect? Okay, well, seeing none, let's see if we can talk a little bit about a confidence interval for a population proportion. This is section 6.3 if you want to follow along in the notes or in the book. I'm going to start out just with an example and see if we can work our way through an example. And then if we have some success with that or some questions, then we'll answer some questions after that. Let's see if I can get this to focus a little bit better if we make it a little bigger. Okay, so here's the example. We're going to say, what's the chance that a person gets the flu given that they got a flu shot, right? So you go out and get your flu shot, and then we want to know what's the chance that flu shot works, right? And so we're going to sample college students, right? And we're going to take a look at 800 college students in a sample. So 600 out of a sample of 800 college students. Don't get the flu. After getting their flu shot. So we take this sample of our population and we're wondering now, well, what if we talked about all the college students, right, for the whole campus? What would we expect? Uh-oh, that's not working so good. They're struggling with the internet a little bit. Is that coming through for you guys? Can you see it?
Kind of.
Kind of. It's a little blurry.
It's a little bit blurry, but it works.
Okay. Yeah, it looks like we're getting some lag. Yeah, it looks like a little bit of lag. We're going to have to just do the best we can. I don't know what we'll do if the internet goes down. Then we'll have to just send some things back and forth. But this example, there's a couple examples in the book I'll show you, and then you can see one that's printed a little bit better. I would like to try to carry on live here if we can, but Yeah, our lag is struggling just a little. There, it's in focus. Okay, well, let's keep going and see how we do. What we would like to do is take this sample, and we would like to estimate the population proportion. So we're going to say, well, okay, if 6 out of 800 in the sample didn't get the flu, then we would estimate the population proportion P using the sample proportion. So for the sample proportion, we usually put a hat on the P and say P hat, which is 600 out of 800, or about 6 out of every 8, or about 75%. So 75% of the people who get in our sample who got a flu shot didn't get the flu. So it worked 75% of the time. And so we might estimate the population standard deviation or the population proportion the same way. We'd say, okay, great. I'm thinking that 3/4 of everyone then would have a successful flu shot. But we would like to know, okay, yeah, that's great. But what if I took a different sample? I would get a different proportion. And then, how do I know how accurate this estimate really is? And what we want to do is build a margin of error. So the error in this estimate is the difference, right? So the error, the actual error is the difference between the true proportion and what we get for our sample. So maybe that's plus or minus 4%, plus or minus 5%. And here's how we're going to calculate it. We want to consider the sampling distribution of the sample proportion. So what we would do is we would take lots and lots and lots and lots of samples of size 600, and we would make a big histogram and see what it looks like. And it turns out that the distribution of all the sample proportions would be normally distributed with a mean that's equal to the population proportion and a spread that's a P hat, that's equal to the square root of PQ over N. And what this is telling you is that if I did lots of samples, I would expect them to all be right around 75%. But a few of them, I might get, a whole bunch of people that got the flu, or a whole bunch of people that didn't get the flu. But the chance of getting that sample would be really small, right? There'd be a very small chance. And so what we want to do is say, for a given level of confidence, how big is our interval? Okay, and we know already that with a normal curve, between 1 and -1 standard deviation, we have 68% of the area. Between 2 standard deviations, we have 95% of the area. And between 3 standard deviations, we have almost 99% of the area. So we're going to take a specified level of confidence. So given a confidence level of, say, 90%. Hey, are you online? Nobody's online. Yeah, I'm like breaking up here. I'm just barely working.
Cox is can't get DDoS yesterday. So I don't know about today.
All right. Okay, so given a confidence level, like say 90%, we're going to need to find the Z, or the critical value, that cuts off, right? Cuts off 90% of the area. So we're going to say, I want to know where 90% of these sample proportions are going to fall. Okay, and to do that, we're going to either look in the book, look on our calculator, or use StatCrunch. right, to find the critical value. And so using a calculator or the back of the book, the table gives us all the area to the left of a particular z. And we want the area between minus z and positive z. So we want this area in here to be 90%. That means there's 10% left over, 5 up there on the top and 5 down here on the bottom. So to the left of a particular z, we would have this 90% we want plus this 5. So we're going to look in our table and say, find the inverse normal of 95%. Okay, that seems a little weird because we're looking for a 90% confidence level, but we have to look to the, we have to use 95 because we have to include this 5% when we're looking to the left of a particular value. So if we look that up using the calculator, we're going to say distribution, inverse normal. And we're going to look up 95%. Oops, yep, 95%. And we're going to get 1.645. So this is the same value that we got in the last 2 sections for our critical value. And you can find this in the back of the book or using Desmos the same way as we did in section 6.1. Given that we've got a particular critical value, then we're going to calculate our margin of error to be the critical value times the standard deviation of the distribution of the sample proportions. Which turns out to be z sub c times the square root of PQ over N. Now, we still have a small problem, and that is that we don't know P and Q. In fact, we're trying to estimate them using our sample. And so given that we don't know them, we're going to estimate them using the sample proportion. And that's going to create a little bit of error. And so when we did that in section 6.2, we noticed that we had to use a student t-curve instead. But it turns out that for population proportions, it'll still be normally distributed given that the sample size is big enough. So we're going to check that NP is greater than or equal to 5 and NQ is greater than or equal to 5. And if that's true, then our distribution will still be normally distributed or approximately normally distributed. And we should be good to go. Yeah, sorry about the internet. We're doing the best we can there. I'm trying to get it to focus. It's just so laggy that it won't come back in focus. Okay, there we go. So in our case, we had 600. We sampled 800 people. The population proportion was 75%. So 75% of 800 is 600, clearly bigger than 5. And the chance of failure, 25%. So 25% of 800 is 200, also bigger than 5. So it's okay to use the normal distribution to approximate our margin of error. All right, so let me flip over to the back. Our margin of error then, okay, waiting for the lag. There we go. Our margin of error then is z sub c square root p hat q hat over n, which in our case was 1.645 times the square root of 75% chance of success, 25% chance of failure, divided by our sample size of 800. When we do this calculation, we're going to end up with 1.645 times the square root of 75. I don't need that parenthesis. Oops. holy moly, the square root of 0.75 times 0.25 divided by 800. And we get 0.025 or so, meaning that we've got a 2.5% error in our estimate. So we can say that our true population proportion, right, our population proportion is in the interval or about equal to our sample proportion plus or minus the margin of error, which is population proportion, 75% plus or minus 0.025 or 2.5%. If you want to write this as a confidence interval, then we take 75 minus 2.5, and we would get 0.0725, right? And it would go up to, adding 2.5%, 0.775. So based on our sample, we can be 90% confident that the true population proportion falls between 72.5% and 77.5%. Questions?
Nothing so far.
Nothing so far. Okay, I apologize for the laggy internet and the camera not being able to focus because of the lag. What I will do is I'll just scan in what I wrote down, and I'll just add it to the notes page so that if you want to look at it, you know, without it being blurry, you can grab it at the end of the meeting.
That would be really helpful. Thank you.
Okay. All right. So let's look together. Maybe this will come across a little better. I'm going to share my screen, and let's take a look at the notes. So I'm going to zoom back up here. That's actually showing up pretty good on mine. Hopefully that's a little clearer on yours. We want to find a point estimate, construct a confidence interval, and then we want to work backwards. We want to say, if we need to be this confident, about how big a sample size would it take? Okay, so the first thing we're going to do is a point estimate. And to do that, we're just going to take a sample. We're going to find out what proportion of our sample said yes, or met whatever the criteria are that we're doing in this particular example. And we're going to use that to estimate the population proportion. So here's a nice example about Facebook. It says, I wonder how many people use Facebook. 10% of the people use it, 50% use it, how many? And so what we do is we take a sample. They took a sample of 1,550 US adults, and out of those, 1,054 said they used it. So if you want to know what the proportion of the whole population is, we can just use this for a point estimate. In other words, you would just take the 1,054 that said yes and divide by the 1,550 that you surveyed, and you would end up with 1054 divided by 1,550. You'd end up with 68%. So you'd say, well, 68% of my sample said that they used Facebook. So I'm kind of thinking that maybe 68% of the whole population uses Facebook. Okay, but now of course, it depends on which sample you took. So certainly there are, 1,000 people that use Facebook. So if you were really unlucky, you could have picked a sample where everybody used it, or a sample where nobody used it. But most of the samples should be lumped up, right, somewhere around 68%. And so what we want to do is determine how spread out are all those possible samples so that we can come up with a confidence interval for this estimate. Okay, so to do that, here's a nice little set of guidelines that you can use when you're working on your homework problems. You're going to identify the sample statistics. You're going to make a point estimate like we just did. You want to verify that it's okay to use the normal distribution to estimate the confidence interval. And to do that, we need the NP and NQ to be bigger than 5 so that our distribution turns out to be normally distributed. Find the critical value. Of course, in the book, it says to use the book, but you can use your calculator or StatCrunch or something like that. Calculate the margin of error, and we're done. So let's see if we can do that. Here's one all nice and worked out for you. I'm going to try the same one using the calculator so that you can kind of see it worked out on the calculator. So let me write down all the critical information. We want a 95% confidence interval for this population proportion, 68%. I'm going to stop sharing that, see if we can get the camera to work for us. Okay, so what will we do? We would first check that n, this was p hat is greater than or equal to 5. So NP hat is 68% of our sample of size 1550 is going to be our 1054. So yep, bigger than 5. And Q hat is the rest, right? 1 minus 68% times our 1550, which is going to be, what is that, 32%? So 32% of 1550 is 496. Also bigger than 5. Okay, so then we're going to calculate our margin of error, which is our z sub c times the square root of p hat q hat over n. Our z sub c is going to be the z that cuts off 95%. To do that, we're going to look on our calculator here and say inverse normal. So distribution inverse normal. Remember that we have to add the 2.5% to the 95. So we're going to say to the left of 975 and get 1.96. Notice this is the same value that we've been getting for the last several examples for a 95% interval times the square root of p hat, which is 68, right, times q hat 32 divided by 1550. So working that calculation out, 1.96 times the square root of 68 times 32 divided by 1550 equals 0.232. So about 0.23, 2.3%, or a 2.5% or 2.3% margin of error. So then our confidence interval is going to be our estimate plus or minus the margin of error, which is 68% plus or minus our 0.023. So it's going to go down to 68 minus 0.023 or 657. And up to, if we add that, that's 70.3. So up to 70.3%. Okay, so down 65.7 up to 70.3%. If you want to use your calculator to sort of confirm the answer, it will do the whole calculation for you in sort of one step. So will StatCrunch, right? So will many other programs. Pick one that you like and then use it. I'm going to use the calculator today. It's under Stat, go over to calculate, and then it's, go further over to tests, and then keep going down here. Notice that it does the tests before it does the confidence intervals. The tests are actually in chapter 7. They're coming up next. And so we're down here at the intervals. There's a Z interval, and here's a 1 proportion Z interval. So it's A on the calculator. And push enter. We're going to put in our numbers. We had 1,054 say yes. We had 1,550 in our sample, and we want to be 95% confident. If we push calculate, we get, hopefully that's the same, from 65.7 up to 70.3. So those are the same answers that we got. So your calculator can confirm. This is kind of nice if you're working on MyStatLab and you want to just check your answer before you put it in. Okay, so that's how you find a confidence interval for a population proportion. There's a bunch of homework problems for you to practice on. Why don't you give that a try here in the next couple of days. And then if you're stuck, you're always welcome to come back to office hours and ask questions or send me an email, and I'd be happy to sort of work with you and try to figure out what's going on. Any questions?
No.
Nope. Okay, I'm getting
Not from me right now.
okay. I'm getting a few nopes in the chat as well. I think that that's probably enough for today to get us started. You guys should try the homework problems, like I said, and then if you find that you're stuck, you know, write me an email or come back during office hours and we'll see if we can get you moving. I will look into what's going on with our lag and see if I can find a better solution than this. And I'll go ahead and post our conversation today and the notes, if I can get them scanned in, I'll post them on Canvas so that you guys have them. And I'll follow up with a little email kind of letting you know what we talked about testing for next Tuesday. So if that's it, I think we can wrap it up for the day and let you guys get going. If you want to stay around and ask questions, you're welcome to. Otherwise, I'm going to see you on Thursday, and we're going to do a little experiment. So if you get a chance, pick up a handful. You need like 10 Hershey's Kisses so that we can do a little activity together. We'll do that on Thursday. Is that it?
Yeah.
Okay. Guys, have a great afternoon, and I will see you on Thursday.
All right.
Bye.
Thank you.
Mhm.